Alright, what's up guys? So today we're just going to be looking at limits at infinity, kind of as a continuation of what we were doing earlier with just basic limits and L'Hopital's rule. So as you should know, with limits, it's like as x approaches 2 here, you know, like it's going to equal 2 because that's what this line approaches. You see what I'm saying? Like from x to 2, it's like going to be that because like y equals 2. So like with this instance, what you're basically just gonna do is you're just gonna say, hey, if I plug in infinity in this, I'm gonna get infinity minus infinity, which is not okay. That is indeterminate form, and that does not tell you anything about, any of your, any of this function, any of this equation, and anything about what it does when it goes towards infinity. Indeterminate form is hilariously useless. Uh, all it does is tell you to use something else. So essentially, what I'm just going to do is I'm just going to say, okay, I'll take out an x. No, because I'll still have infinity over infinity. Okay, I'll take out an x squared. Okay, well, then I get infinity uh, minus 1. And that still equals infinity. Um, but it's just, you know, it's not a very good practice just because if you're just taking out some uh if you're just taking out some like degree in the middle of your problem, it doesn't really like show you anything. It's or it doesn't it, I mean it gives you the right answer in some cases, but it's very limited in its use, and it's very easy to you make a mistake that you end up regretting. That will give you a wrong answer very often. Like, let's say I have some function with like 7 degrees, because you will see that in when you're doing limits at infinity, because, they're pretty easy, so having degrees is basically how you do the problems. Knowing degrees and how high the exponents is how you do the problems. So, just picking some random one in the middle is not a very good practice, just because of that, because you're just going to have to take it from everything. It's just a big pain. So, what I like to do is I just suggest, okay, just take the highest degree, which in this case is x to the fourth out. So let me write my limit. So 2 minus 1 over x squared, because you're subtracting x to the fourth from x squared, which is just x to the negative 2, minus 8 over x3. So let me tell you something about calculus, if you haven't noticed this already. Splitting things up, whether you're doing derivatives, integrals, or limits, any of the 3 parts of calculus, is going to make your life 10,000 times easier. You are not only going to you're going to actually like fully decrease the amount of stuff and variables that you're dealing with, but you're also just going to straight up decrease the complexity, which I guess those are kind of like the same thing, but you're decreasing complexity as much as you can. So let me just do that real quick. And what you really want to do here is just solve these individually. It doesn't matter what order you go in, because you're gonna kind of do the same thing. So this obviously infinity. You plug in infinity to x to the fourth, it's going to go to infinity. Here it's a little less obvious, but 1 over, or any number over infinity, which x squared is an x to the cubed are obviously infinity, will approach infinity on their own. But 1 over something like that, 1 over infinity is what? Well, if you think about it, 1 over 1 half equals 0.5. 1 third equals 0.33. 1 fourth equals 0.25. You see how the higher my bottom number gets, the lower it actually becomes. This is kind of like fourth grade fractions to an extent. You know, the higher your lower number, the smaller it actually is. I'm sure you've like heard that like a million times because of the piece. So 1 over infinity must be pretty small, and the higher that it gets, um, the closer and closer to zero it gets. So your limit is actually just zero. Whenever you have 1 over any variable, it's always and it's at infinity, it's zero every time. Even if it's tending towards a negative infinity, it's just doing it from the other side. So this is zero. So 2 minus 0 is just 2. Now, you won't get many of these sorts of problems where they're not rational expressions. You won't get many of these sort of like, straight line 2x to the fourth minus x squared minus 8x sort of type of problems. You won't get many polynomials or quadratics is what I'm trying to say. You'll get rational expressions only. So knowing these next like formulas, I guess, is not really that necessary. Um, so okay, let me kind of explain this a little bit. Say that this is b. This whole limit here is b, and then this whole limit is a. Just this x to the fourth limit is infinity as x to the fourth, and then this 2 minus 1 over x is b. Whatever these equal is what they are. This equal to, so b is equal to 2. This equal to infinity, so a is equal to infinity. Let's say that bl, or not l. Let's say that b, if b is greater than infinity, or greater than 0, I mean, and let me actually just look up the fact here. It's a formula, so it's not that useful. So if this is true, then then f of g of x, this three dot thing right here means therefore, then f of x, g of x approaches infinity. Or it equals infinity. You can't equal infinity because it's not a number, so approaches is just the same idea. If it's less than, it equals negative infinity. If it's less than 0, f times g of x, or whatever the fuck, sorry for swearing, f of g of x equals negative infinity. Basic, like, everybody's heard of this, bro. Like, no. No one even cares about these stupid freaking formulas that don't mean anything. So 2, so yeah, this approaches infinity, which is pretty obvious, because infinity plus 2 is infinity. So I mean, just from that, you shouldn't even have to know these formulas if you can just realize, oh, if I add, multiply, or subtract, if I do anything other than divide 2 divided by infinity, it will equal infinity, which I have no idea why you would even be doing that. There's no way that you would ever divide 2 divided by infinity in this instance. So, yeah, this approaches infinity. This whole limit, 2x to the fourth minus x squared minus 8x equals infinity. Or, as the AP exams will like to say, does not exist. Even though that's not true at all, and they kind of go willy-nilly between does infinity count as a does not exist, or negative infinity in that instance count as a does not exist, or does it actually exist? On AP exams, they use both. Like, sometimes you'll have like a question like this, and you'll have A, B, C, D, E. You'll have A through D will be like in numbers, and then E will be does not exist, and your answer will be infinity. But you'll have to write does not exist, and then the next question after that, you'll have the same exact idea, but instead of it saying A, B, C, D, E, it just says A, B, C, and then D, E are infinity and negative infinity, and you have to pick which one it is. So they use both willy nilly, and it really is quite annoying. And but that's just the nature of it. You have to be able to tell that this is also DNE, that any of the infinities is also does not exist and could be. On an FRQ, if you got something like this, always write both. Or Or if you don't, make sure you write infinity or negative infinity, because AP does know that calculus teachers, in textbooks disagree and will write different things. But essentially, that's how that works. So let me find one that's a rational expression. Okay. So rational expressions, let me scroll, get that trash formula out of my face. So rational expressions, the thing about these things is um the way that you find plus 8x divided by negative 5x to the fourth plus 7. The way that you do these sorts of problems is very different from what I just showed you. When you have a function over a function, like I knew as I was writing this problem what the answer was, and I had not done any math in my head at all. When you're doing these types of problems at infinity or negative infinity, it's what are there what are the degrees and what are the leading coefficients? So in this instance, I see that the highest degree is 4, is x to the fourth. So I say, okay, let's say I saw the top one first. I say, okay, I see 2x to the fourth is the highest degree on the top side. Okay, does the bottom have an x to the fourth or higher? If it does, then I know that it approaches 0, because x to the fourth over x to the fifth, limit at infinity, this approaches 0, obviously, because this is just 1 over x. Once you simplify and get all this, once you subtract, 4 minus 5 is negative 1. So x to the negative 1, which is 1 over x. So this approaches 0, obviously. Limit as x approaches infinity of x to the fourth over x to the fourth. Okay. What you do here is you do x to the fourth minus 4, which is x to the 0, which is just 1. So your answer here is 1. Say that I have x, or limit as x approaches infinity of, I don't know, x to the third over x to the fourth. Or not that. X to the third over x squared. Okay. Because x to the fourth over, yeah, it was just the same as this, or this. This, because you do 3 minus 2 is just x, and limit as x approaches infinity of x is just infinity. So this is just infinity. Sorry if this is like so horribly like messy. It's all about your degree. If your degree on top is higher, then it's always infinity or negative infinity based on what the limit is approaching. If it's approaching negative infinity, it's negative infinity. If it's approaching infinity, it's infinity. If top and bottom are equal, I should have wrote equal in between instead of the and, then it's whatever your coefficients are. It's whatever the number in front of your x to the fourth or x to whatever is. So if it's, let's say in this instance, it's just negative 2/5, because these cancel out, so it's just negative 2/5. Let's say bottom is higher, then it's 0 every time. Because no matter if it's positive infinity or negative infinity, because anything over an x limit at infinity will equal 0, because of what I showed you before, where 1 over x equals 0 at infinity. These are your holy grails to solving this problem. These are the scrolls. These are the holy books that fucking Luke Skywalker, that Luke Skywalker had in his the holy scrolls, dude. These are the legendary scrolls right here. This is what you need to know for any exam you take where you do limits at infinity. This is how you do these 3 rules right here. So yeah, that's it. This is it. Thanks so much for watching.